Okay, pick that back up in the middle of the example. I said I cannot combine the two logarithms here because they're unlike terms. But if I go to the other side, notice that there is a common factor of x. To get the x by itself, this is a weird step, but it goes back to what we did with factoring in chapter 5. Yeah, we did all that factoring with polynomials and stuff. So here, we're going to pull an x out, and we're going to be left with log of 2 plus 2 times log 5. The log 2 is gone on the left. On the right side, I get log of 5 minus the log of 2. Alright, so we're going to just solve for x. To solve for x here, this is multiplied. I got to divide out this big expression in parentheses. So I'm going to divide that on both sides of the equation. It seems a bit unnecessary to keep this all written out, but it is actually very important. Can't really simplify. We're going to simplify in a few minutes, but there may be reasons why or times where we can't simplify or need to keep them separate. Alright, so on the left side, these all cancel out. On the right side, I'm left with just log 5 minus log 2 all over log 2 plus 2 log 5. That would be a sufficient answer, and I would take that answer even though it looks complicated. There are ways to simplify this using our log properties, and you know, I guess I could do that here just so you can see, but this would be a sufficient answer for me, although my math lab may want something different. So let me finish this off by simplifying in another color so it looks a little different here. The difference of the two logs, log 5 minus log 2, can be simplified again using property 8. The difference becomes a quotient on the inside. So I'm going to rewrite this as the log of 5 divided by 2. Notice on the bottom, this 2 coefficient will become an exponent inside the argument, so I'd have log of 2 plus log of 5 squared, which is 25. Okay. Now, I can continue to simplify this. On top, 5 over 2 is 2.5. Right? 2.5. And on the bottom, when I add two logs, I can combine them by multiplying the arguments. So this becomes the log of 50. Right? 2 times 25 is 50. And now this is kind of nice, except I could use the change of base formula. Notice I've got two logs that are the same base. And as long as I have a fraction with the same base, I can use property number 10, the change of base formula, to simplify it into a single log where the argument from the bottom is the base, argument from the top is the argument. Okay, so argument from the bottom is the base, and the argument from the top is the new argument. So I get log base 50 of 2.5. Alright, so that would be a great answer. It's nice and simplified. It's an exact form. I've never rounded anything off. I could also go ahead and find the decimal approximation for that. So on my calculator, I could try log of 2.5 divided by the log of 50. and that gets me approximately 0.234. Alright, now again, my math lab, I don't know which form it's going to take. It could take really any of these three, the very unsimplified, or any of the ones on the bottom, maybe 4 different possibilities. I'm going to go ahead and use this simplified exact form in my solution, but I would be willing to take any of these answers. Okay. Again, I don't know what my math lab will take, but just be very sure to read the instructions on the My Math Lab problems, because it's usually pretty clear from the instructions what form it wants. Alright, I hope you guys enjoyed this. Enjoy your weekend. Get lots done. Watch some math videos. And really try to take your mind off all the stuff out there in the world, and you know, enjoy some math. Lots of entertainment this weekend for you. Alright, take care.